Okay, we're going to talk about S11A, Introduction to Periodic Functions. I'll do the warm-up second, but I want to first make sure that we understand the main topic here, which is dealing with the radius of Freddy's water wheel. So we did a Desmos activity today, and the most important thing is when we look at our results. So what is the radius of the water wheel? So in our exercise today, our radius was equal to 1. It was 1 meter, I believe. Okay, and then as the water wheel moved around, we started it there, and then it moved up and up and up. We noticed the highest the water wheel got was a radius of 1, and then it moves around, and then the lowest it got to was at -1, and we filled out the tables to help us make a connection between the rotational degrees and the height of the water wheel. You may want to hit pause and copy this down, or check your answers from today's activity. And then, so what did we notice on the way down? We noticed that the heights are symmetrical on the way up and the way down. Okay, so plotting some of these points from the table, you get something that kind of looks like this. And noticing that it's symmetrical on the way back down, it should look the same sort of pattern. Okay, and so the question is, what does the level of the water wheel represent? And the water wheel represents the x-axis. But tomorrow we're going to be learning that this is called the principal axis. And that's what we're going to be focusing on tomorrow, is this orange line, and it's going to be moving around. But right now, the orange line is not moving around, and we're calling it the x-axis, but it's going to be, we're going to refer to it as the principal axis starting tomorrow. Okay, can you predict the height of what the water is going to be? And yes, you can. Basically, when it goes underneath the water. So when the frog goes under the water, it's going to have the same sort of pattern. We know that it's not going to go below -1. And there we go. So now, here's the thing that we need to talk about. So with the graphics gone, you can see that the right triangle within the rotation, the red side of this right triangle is the opposite. So on your computer program, this was the red side. Okay, and that represents the height. Okay, and this is the opposite side of this angle. This is the opposite side of the angle. So, and the dotted line, which is this dotted line here, is the radius. And as we said before, the radius of the circle doesn't change. So my radius is equal to 1. So if I've got this height over 1, well, height over radius using SOHCAHTOA is equal to sine. So basically what we have just drawn when we were watching the angle degrees and the movement of the frog, we were actually drawing a sine wave. Okay, so now it says try it out, plug it into your calculator, and when you plug it into your calculator, you've got sine 0, sine 90, type them all in, okay? And after you type it in, check your answers and hit pause. Okay, now let's talk about question 3. I think it's an important question to discuss. Okay, so question 3 says, okay, so in quadrant 1, we're between 0 and 90 degrees. Okay, so between 0 and 90 degrees is this part of the graph right here. Okay, and so when you look at the y values, or the range, you would say that this is positive. Okay, so what if I'm between 90 and 180? Well, if I'm between 90 and 180, it's also still positive, right? So between 0 and 180, we're above the x-axis, and so sine of theta is going to be positive because our graph is above the x-axis. Okay, so now let's talk about the other quadrants. The other quadrant goes from 180 to 270, and then from 270 to 360. And for both, for between 180 and 360, you can see that the graph for both parts of that is below the x-axis, which is going to be negative. You might want to hit pause and copy this down. Okay, lastly, okay, state the range of possible values. Okay, so once again, we just saw this graph like this, right? So the highest it went to was 1. The lowest it went to was -1. So my range is between -1 and 1. Okay, maximize. So let's so the maximum happens here, and the maximum value happens at 90 degrees. So what value of theta gives us a maximum? When theta equals 90 degrees. Because at 90 degrees, we're at the maximum. Okay, so the minimum is going to be at 270 degrees. So a minimum happens when theta equals 270. Okay, 0. There's 3 points when it's 0, when the height is 0, and that happens at 0 degrees, 180 degrees, and 360. So when theta equals 0, 180, and 360, our height of our graph is 0. Okay, positive. We just did this. For theta between 0 and 180, it's positive. So 0 and 180. I shouldn't have put that on. Okay, and it's negative between 180 and 360. Okay, and now draw the rest of the graph. So so starting at 0, we know that at 0, 180, 360. Okay, we know we have a maximum at 90. We know we had a minimum at 270. And so these points help me to draw my graph. Now what's really important is that you do not draw a graph that looks like that, because I'm going to draw a mean face. Just kidding. So it doesn't have sharp points, but it does go to this maximum and this minimum. So when you're drawing it, you need to have a smooth curve. Okay? Now, draw the rest of the pattern. So the pattern is going to repeat, because when you think of the water wheel, let's look at our water wheel. The water wheel, once it gets back to 360, it repeats the same pattern. And it continues to repeat the same pattern over and over and over again. So our water wheel, so once again, so it goes to the maximum here at this point, then I go back to 0, then it goes to the minimum, then back to 0. And so it's going to continue the same pattern. Okay. Now what about negative values of theta? So at negative 90, negative 180, negative 270, negative 360. So here I'm first drawing. I messed it up. Okay. Okay. So between 0 and 360, it looks like this. So now we're going to talk about negative values. Just like the water wheel, if I was doing this backwards, it would still have the same pattern, and it would just connect nicely here. So okay. So if this moves like that, or if I move from here to here, you could see that the pattern just repeats. Okay. Now this is a good question right here. Explain why sine 130 equals sine of negative 230. So if I use my calculator, and just for fun, I'm going to type in sine 130, and I get this value here. And if I type in sine of negative 230, I should get the same thing. And notice I do. So let's look at this graph here. Sine of 130, here's 180. 130 is something like about here, and it's 0.76. So 130. Okay, so at 130, I'm right there at about, what did we say? It's at 0.7660, right? And that's our value there. And then sine of negative 230, it's at the same height. So negative 230 is sort of like right there. Negative 230. You can see I'm eyeballing it, but the idea is if I go to negative 230 and then up, I get the same value. So explain why these give the same answers. And I think the important thing to really recognize is that these have the same height above the x-axis. Okay. Now, is this a reflection on the x? Can this graph be a reflection on the y-axis or the x-axis? And the answer is no, because if I have this part of the graph, if this was reflected over to here, then this blue upper arch would be over here, which is not on top of the orange part. So it's not a reflection on the y-axis, because this blue part would have to match up on top of the orange part if I folded it over. Now what about the x-axis? If I folded this blue part down over here, this doesn't land on top of the orange. So it's neither a reflection on the x-axis or the y-axis. But does this have rotational symmetry? And the answer is yes. And I want to show you why. If I do this, and rotate means twirl, right? If I twirl this around, notice this, the way the blue arch looks. If I twirl it 180, this is in the same spot that the blue arch, the blue wave used to be. I'm going to twirl it 180 again. So if I twirl it 180, I do have rotational symmetry. Okay, I will put the warm-up in a separate video.